All right, so we're talking with Rachel Howard about the use of next generation science storylines in the classroom. Rachel has had a little bit of experience because she's used it at least in 1 or 2 lessons this semester in your classroom. Is that right?
Yeah, we used it for a thermodynamics unit in chemistry class at
Can-
the
can-
high school level.
Can you explain, first of all, like what is it and how does it play out in a lesson?
Sure. So the idea is built off of the ambitious science teaching sort of pedagogy. But the Next Gen Science Storylines website takes it to sort of like the next level of having a digitally prepared curriculum that's ready to go for science teachers to implement this kind of teaching in their classroom. So the overarching question of the unit was what makes things get hotter or colder when they react, which, as you can already see, is like a more engaging way than saying like, let's talk about thermodynamics.
Yeah.
Like, therein lies the challenge. And when you work with a curriculum where everything is already laid out, like the student packets are already prepared. Like, if you wanted to, you could just print 130 pages of student packets and have them fill in the blanks. All of the questions are there. The teacher lesson plans are there, as well as like the back pocket questions that you want to have while students are working to kind of tease a little bit more out of them and get them to think through what they're doing. And so with my teaching group, there was sort of one strategy was like, well, we're pilot teaching this lesson. We've never used this source before. And so we owe it to ourselves to be as true to how the curriculum was described.
Yeah. You're test driving it.
Right.
So, yeah, you don't want to like...
Yeah, so that we would, have a real sense of like, does this work? And if it doesn't, it's like on the curriculum and it's not on us.
Yeah, right.
But when you get down to the day-to-day planning, you'll realize like, I don't even know how many lessons what makes things get hotter or colder when they react. I don't know exactly how many lessons it would have encompassed, but I want to say it would end up being like well over 2 months worth of teaching. And we just... Right. So I think like the first couple of days we were really quite true to how the curriculum had described things. And then I think we kind of reached this rhythm of understanding like how the curriculum was outlined and what kinds of questions we were being prompted to get our students thinking about. And like once we became more comfortable with the way that it unfolded, I think we could give it our own spin. And then there were other things that just in the nature of having this curriculum available on a website rather than hearing about it from somebody who had taught it, or like being able to have face-to-face conversations with the developers, there were some things that were described that were really not clear to me. And when I talked to other teachers, we kind of pieced together what we thought was being said, and there was one key sort of like exploration activity to help students get to a certain principle that we didn't understand the setup of that activity until the very end of the unit, after the students had already... there was sort of like a physical simulation that students were going to work with, which was an intro to a much more sophisticated online simulation. And when we got to the sophisticated online simulation, we were losing students left and right. They were like, what is this? And that's when we realized how we could have designed the physical simulation to just be like one mental step below this online simulation.
No, I know
and
what you mean.
we didn't have a vision of that sort of like arc of the curriculum. And so I think that's kind of an example of how like when you take something that's just described in writing or described online,
a prepackaged
like, you really have
thing.
to just teach it.
How did it go?
So I think at the beginning there was a lot of engagement, which was interesting. Like I didn't think that the initial experiments or whatever we were exposing students to at the very beginning were that relatable. Like we took 2 powders, mixed them together, and they were solid powders, right? They formed a liquid, and the liquid got so cold that the beaker that we mixed them in froze to a wooden block. So that's got some wow factor to it, but it's also like, what are you doing? You're just like doing some like sorcery kinds of stuff. Like,
Yeah.
this doesn't relate to our everyday lives. So we did try to like tie that in a little bit more and have some experiences that students could relate to, like those instant ice packs where you pop
Yeah.
the thing and then it gets cold.
Yeah.
So there was like either just from like the spectacle of the initial day or tying it into more relatable things like ice packs or things like talking about like ice cream melting in your mouth or something like that. I think we were able to get a lot of student engagement really early on. That only carries you through so far.
Yeah.
And as the lesson, as sort of like the unit went on and spanned more and more days, I think we kind of like lost students along the way.
Yeah.
And they failed to see the connection.
Yeah.
One of the interesting ways that we were able to get students back, though, was on the original day, and then periodically throughout the unit, we'd have students put questions up on like a big class question board.
Mm-hmm.
And every so often, we would have a moment where we would look at the questions and maybe as a warm-up, identify a few questions that we could now answer.
Oh,
and that was
cool.
really cool because the questions weren't, they just came straight from the students.
Yeah.
And to be able to see this, like, here's a question that we posed, and now we've got the tools to answer that.
That's
I thought
very
that
cool.
was really cool
Yeah.
for me to see as a teacher that like we actually built the skills that they could do that, and I think the students felt really gratified from that too.
So.
That's interesting. Yeah, the online materials did not provide any sort of assessment, so that was up to us to come up with. And one of the scientific practices that we were really trying to focus on with this unit was to explain something at the unobservable level through a model.
Yeah.
And so we did a lot of modeling, like from the first day of just seeing those powders mixed together, like trying to think about like on a molecular level what might have been going on, even though we didn't necessarily have an answer.
Yeah.
To like, as we gradually understood more and more of what was going on, having more sophisticated models.
Yeah.
And then eventually being able to tick off like all of the things that the models could explain. So like the movement of molecules or conservation of matter, and then even more sophisticated, like by the end of the unit we were talking about like trade-offs between potential energy and kinetic energy, and that students could actually create a model that would show that trade-off.
That's really cool.
It was really cool to see students' models become much more sophisticated.
Yeah.
Yeah, I strongly recommend the curriculum. I think maybe it's helpful to know going into it that there are going to be some bumps along the road as you're test driving it. But yeah, it's definitely a great way to approach this sort of ambitious science teaching and getting students to really engage in a scientific practice or maybe multiple scientific practices. And yeah, I think it can work really well. And then just to kind of reflect as each day goes along to think about how it could be tweaked for redevelopment in the future. Because just because it's laid out a certain way online doesn't mean that that's necessarily the way that you need to carry out the unit.
So it's almost like any curriculum. You've got to learn how the structure or the system of it works, and then tailor it to like your needs, right?
Yeah.
Awesome. It sounds really cool. I hope I can use it someday in some way in a classroom. Thanks so much for sharing with us, Rachel.
You're welcome.